Okay, hello, welcome. In this video, I'm going to be going back over Calculus BC Unit 5 to help you as you're preparing for the unit test, right? So here I've got the notes booklet that I gave out for this unit. And just to remind you, the Unit 5, it's all about differential equations in this class. And so, we're kind of a ways into Unit 6 right now because of, some circumstances that caused us to have to take the test later. So I'm just reminding you of, what did we do in that last unit. Okay, so we started off with slope fields, which was kind of like the graph of a differential equation. Okay, we sketched them. That was where we made our own tick marks. We could sketch solution curves. That was where we started with the solution, or we started with the slope field and sketched the solution. We tried to stay in the lines, follow the lay of the land, whatever. And then we had some multiple choice items that went along with that, and that's probably, I've got some problems we can look at there. Then we learned about how to anti-differentiate, which really just kind of, at this level, at this point in the year, our antiderivatives, they just follow directly from derivative rules. So you just got to know your derivative rules, right? Definition of an antiderivative, power rule, that's big, and then the minor chain rule difficulties where we have a composition of functions and the interior of the composition is linear. Okay, we do need to be able to deal with that. Okay, obviously trig antiderivatives, solving basic differential equations, and we did a lot of examples that day. Okay, separation of variables, the general solution is not as common in AP Calculus as the particular solution. That's a very, very common item. We're going to look at one of those and how it's scored so that you can make sure to do that. And then L'Hopital's rule, okay, that's a really common thing in multiple choice. But on the unit test, you can safely expect to see it in free response as well. I'm looking for a highlighter so I can highlight the stuff that we want. Okay, the thing about L'Hopital's rule is that on free response, we've got to be careful about how we're presenting our solutions to make sure that we maximize our point. Okay, so, and look at that, showing work to maximize credit. Okay, so that's going to be important in this video, so is that, and then I'll just kind of go up and I'll tell you what's important. Important to ensure your success on the exam, right? Okay, anti-differentiation, I'm not going to do a whole lot of these, but, I would say these are the things we need to be able to do. Up here, sketch the slope field, sketch the solution curve, solve multiple choice. Okay, so this is a very finite list of things that we can run through here while I'm recording this video. Okay, so first thing, sketching slope fields. That is, let's see, that is not, I've got that multiple choice quiz, hold on. All right, I found it. So here we go. These are some multiple choice questions. Okay, so which could be a particular solution? That's like the solution curve. So the idea is that, I don't know, they didn't give me a point through, but I know it's got to kind of go like that. Okay, and I believe that is looking like, that kind of looks like the graph of log x. Okay. Not really sure if we would be able to distinguish between log of x and square root of x on the slope field, but we're not asked to, right? We know that e to the x grows pretty fast. E to the negative x decays. X squared, we all know what that looks like. Cosine x, this does not look like cosine x. So log x is the only possibility. Okay. Which differential equation describes the slope field below? This is something that we need to be able to do. Okay, so what I like to do is I like to start with the zero slopes. And so I'm going to say that dy dx equals 0 when x equals what looks to be -1. Okay, and then I'm going to start eliminating based on that. If x equals -1, then dy dx equals -y, which is not always 0. Okay, if x is -1, then I'll have -y minus y is -2y, which is not always 0. Okay, if x is -1, this is always 0, so that's promising. It's a candidate. Okay, over here where x is -1, I've got -y minus 1, not always 0. And I can tell pretty clearly looking at this, if say I scan side to side on these, I can tell it depends on x. But if I scan up and down, I'm seeing it also depends on y, so it can't be that one. Although dy dx is always equal to 0 at x equals -1, it needs to depend on both x and y because as I manipulate y, I'm seeing different slopes. So that's why I'm saying it was that one. Okay. which of the following is the slope field for the differential equation dy dx equals y squared minus 1? Okay, so I need one that where it only depends on y. So if I move left and right, I'm not seeing different slopes. Okay, here, I'm seeing different slopes on answer choice D. Also on C, as I move left and right, I'm seeing different slopes. That would mean that dy dx has to depend on x as well. Okay, this one, again, depends on x and y. And I lost my place a little bit, but I'm thinking, okay, I've got these three eliminated. These are depending on, A and E are depending on Y and not depending on X, so I moved side to side. Okay, so I'm seeing, okay, if Y equals 1 or if Y equals -1, that's going to give me dy dx equaling 0. So I'm thinking that it needs to be A in that case. Okay. That's pretty much what slope fields are going to be like. You know, you might have to color a solution curve or, you know, start with, I don't know, dy dx equals xy minus y, and maybe I'll just do 4 points. You'll have to do more than 4 points, but 1 and 1. So xy minus y. So along the x and y axis, I think, wait, no. At 0, 0, that slope will be 0. That's why I'm doing, I wasn't very explicit here, but I'm doing dy dx equals xy minus y right here. At x equals 1 and y equals 0, it's also going to be a 0 slope. At x equals 0 and y equals 1, I'm going to have a -1 slope. And at 1, 1, I'm going to have another 0 slope. Okay? So that's just a small window into what you might be asked to do. You know, you might be given, say, these are not very interesting. You know, suppose you were given that slope field and it's like, hey, color me the solution curve that goes through the point 0, 1. Is that, nope, wrong one. Okay, that's maybe here between 0 and 2, and we just got to follow the lay of the land, right? That's my first piece of advice. My second piece of advice is that the harder you try, the worse it ends up looking, okay? It does need to go to the edges of the slope field, and it needs to not have any flagrant contradictions to the slope field lines. Okay, and that's, I think, all I need to tell you about slope fields. Right? Sketching slope fields, sketching solution curves, multiple choice. Yeah, we did all of those. Okay, anti-differentiation. Okay, it's really important that you are fully on board with the reverse power rule. Okay, I need you to know that if we have, and kind of like the code, the notation is that this, right, we put a function in there, and this is code for take the antiderivative with respect to x. Okay, and okay, I think what I'm going to do is I'm going to do one with a minor chain rule difficulty, because those I'm realizing are more and more popular with the College Board as time goes on. I'm going to get a blue pen ready, and maybe I'll do some in blue, some in red. All right, so one would be like, I don't know, cosine of 3x minus 5. Okay, this is one where you think, what's a function that has derivative cosine of something? And that's going to be sine. Okay, so I'm going to just start, and we know how the chain rule works. My hypothesis is going to be able to start with sine of 3x minus 5. And I'm not going to forget the plus c, because the derivative of any constant is 0, so all of the different values that c could be represent different antiderivatives for cosine of 3x minus 5. But my advice is always you should check your antiderivative works. So cosine of 3x minus 5 times the derivative of 3x minus 5 for the chain rule. The derivative of 3x minus 5, that's 3, so I need to divide by 3 to prepare for that. Okay? You check it again, that's going to be a valid antiderivative. Okay, there was something else that I felt like, oh, solving, you know, kind of a basic differential equation. That's something you might be asked to do. And maybe I'll try to make sure that we've got, you know, so maybe I've got something like f prime of x equals e to the 2x minus 6. That'll be a good one. With f of 3 equaling, I don't know, Hold on. Just need to be careful. I think 1 will be a good idea. Okay, so we need to say, like, well, what is f of 0? Something like that. Okay, so first we're going to need to find f of x by anti-differentiating. Okay, so that's going to give me f of x is the antiderivative of e to the 2x minus 6 with respect to x. That's an antiderivative. And I'm going to say, okay, that's going to end up being e to the thing is its own derivative, so it would stand to reason that it would be its own antiderivative. But the inside is linear, so I need to make sure to remember to divide by the slope. So that's going to be divide by 2, and I remember to add the plus c, and that's f of x. Okay, now I'm going to need to use, okay, I'm just going to have to lose part of that. I'm going to use my initial condition to find the value of c. F of 3 is equal to 1. So f of x equals 1 when x is equal to 3. 1/2 e to the 6 minus 6 is e to the 0 plus c. I said half and I wrote a third. Get that eraser out. Get that going real quick. Okay, so it's 1/2. Okay. And so 1 equals 1/2 plus c, so that means c equals 1/2, at least me. And now my function is f of x equals 1/2 e to the 2x minus 6 plus 1/2. And then I can find f of 0. Yes, okay, I was going to say f of 0 equals 1/2 of e to the negative 6 plus 1/2. And that's something we can do. Okay, that would be solving a basic differential equation. All right, so let's look back on here. What do we have next? Separation of variables. There we go. So I'm going to bring in a problem that was from the 2018 Calculus AB exam. I'm gonna actually have to print a copy of it first. Okay, so no, I just want to actually print it. All right. Okay. Yeah, let's. All right, here we go. 2018, Calculus AB, free response, number 6. Consider a differential equation dy dx equals 1/3 of x multiplied by y minus 2 squared. Okay, they show us the slope field for that differential equation, and while I'm here, I might as well just do that. Okay, so it's gonna, kind of go like that. All right, no flagrant contradictions. Go to the edge of the window. Don't try too hard. I don't know what else to tell you. Okay, we would definitely be able to write an equation for the tangent line and use the equation to approximate f of 0.7. We could do that if we needed to, but I saw y'all do that on the last unit test. I know y'all were good at it, so I'm not going to waste your time with that now. Find the particular solution y equals f of x to the given differential equation with the initial condition f of 1 equals 0. That is separation of variables. That's what you need me to show you. Okay, so we're going to go all the way back up there with f of 1 equaling 0. So let's just see, maybe I can fit that in right here. Zoom in a little bit. All right, so first step, separation of variables. So divide both sides by y minus 2 squared. Okay, leave the dy over here, then multiply both sides by dx. Okay, my advice is always going to be to, if you've got a constant involved, leave the constant on the side with the x's. It just will make your life easier. And that's equal to 1/3 x dx. And we can anti-differentiate both sides. So that's going to be negative y minus 2 to the negative 1 power equaling increase the power by 1, divide by the new power. So that's going to be 1/6 of x squared plus c. Now we're going to start trying to solve at y, so I'm going to get rid of that negative. And I might write the negative 1 power as 1 over y minus 2 equals negative 1/6 of x squared plus c. Remember, we don't do algebra with plus c. Okay, now if 1 over y minus 2 is this, then y minus 2 is going to be 1 over that. And then I'm going to just take this all the way before trying to find the plus c, or the value of c, and I'm going to say y equals 2 plus that fraction. 1 over negative 1/6 x squared plus c. All right. This is a little annoying, but it's going to be all right because they're saying f of 1 equals 0. And, well, I didn't even fit this all in on screen, so I'm going to have to zoom out, I guess, and bring in a new Post-it note. You know what I think I might do is I might write this fraction as that thing to the negative first power. Yeah, that's going to be... actually, maybe not. I'll just try to do the best I can in the space we've got. Okay, so f of 1 equals 0. So 0 equals 2 plus 1 over negative 1/6 of x was 1 plus c. Okay, and oftentimes we can kind of just look at this and figure out what c needs to be, but I don't just immediately see it. So I'm going to say, go over here, negative 2, flip it, so negative 1/2 equals negative 1/6 plus c. And I think I'm going to add a 6th, so negative a half minus a 6th, that's a third. It's one of my most useful arithmetic facts. Okay, so c is going to be equal to negative 1/3. Right?
Is there tension in here today?
All right, so I've got c is negative 1/3 and y equals 2 plus 1 over negative 1/6 x squared plus negative 1/3. And let's look at the scoring guidelines real quick. Rather than printing them out, I think I'm going to just kind of label where the points came from, and you'll just believe me on it. You can go look it up. You throw into Google 2018 Calculus AB free response solutions or something like that. Look for the scoring guidelines and scroll all the way down to the bottom. It's number 6. Okay, first point, separation of variables. Boom, got it there. Second point, and third point is antiderivatives. So that's negative 1 over y minus 2 and 1/6 of x squared. All right, yeah, so there's the second point. The third point is constant of integration. It's right here, and uses the initial condition. That's here. Okay, and then the last point is solves for y and has the correct solution. That's that. Okay, remember, 0 out of 5 if no separation of variables, and maximum 3 out of 5, 1 for the separation and 1 for the antiderivative, or 2 for the antiderivatives. Whoops. If no constant of integration. So it's like, don't forget the plus c. You wouldn't want to do that. All right. I think that's all I've got for separation of variables. You have particular solutions, scoring in the free response. We did one, looked at how it scored, and yeah, let's talk about L'Hopital's rule. All right, so for L'Hopital's rule, I think what I'm going to do, I'm going to just work kind of one that's a straightforward limit, one that's got a table of values, and maybe this one with the particular solution to the differential equation. I think that if you need more support on L'Hopital's rule, go back and work that homework again. Those problems are still valid. Okay, so I was thinking number 15. And really the most important thing I need to tell you is maximizing our credit on the free response, because I think that for most of the ones that aren't super crazy, y'all are getting the right answer. I'm not convinced that y'all are going to get the justification point when the time comes, though. Based on what I saw when y'all turned in the homework, it wouldn't have gotten the justification point if it was on the free response portion of the test, is what I'll say. Okay? So remember, we have to show that the thing goes to 0 over 0 or infinity over infinity, right? That's important. We cannot say it equals 0 over 0, because 0 over 0 isn't a real number. Okay, so I'm going to say what happens when as x approaches 1, this is going to log of 1 divided by sine of pi. Okay, and we just plug in x equals 1. Okay, that means that we're heading towards 0 over 0 because the log of 1 is 0 and so is the sine of pi. Okay, that means that I need to use L'Hopital's rule. Okay, we need to explicitly say that we're using L'Hopital's rule. Okay, that might not be something on the test. It just depends. I'm going to have to look at a few of them and decide how I'm going to score it. Depending on what I get back. What I'll tell you for sure is that you will not earn the justification point for L'Hopital's rule on the free response if you say that this equals 0 over 0. The way it was when I scored the AP exam last summer, that's just how it is. Do not be telling me that this limit equals 0 over 0 and so you're going to use L'Hopital's rule. That's just not not something that should be in your vocabulary, right? Equals 0 over 0 equals infinity over infinity. We don't do that. Okay, so this is equal to the limit as x approaches 1 of the ratio of the derivatives. So the derivative of log of x is 1 over x, and the derivative of sine of pi of x is going to be cosine of pi x. Leave the inside the same, take the derivative of the inside for the chain rule, and that's going to be multiplied by pi. All right. And then we're going to try again and see what happens when I let x be 1. Well, I'm getting 1 in the numerator, so that's neither 0 nor infinity, so I know that this is going to be the last step. So this is equal to 1 over 1 divided by pi times the cosine of pi. And I'm going to tell you that cosine of pi is -1. And so that is how we're getting our solution and properly justifying our answer, right? We're going to say that we're using L'Hopital's rule. We're going to show it goes to 0 over 0, but it's not equal to 0 over 0. And that was a good example of a single iteration L'Hopital rule question. All right. Let me find one that's going to be 2. This one. This one will require 2 iterations. So this will be a good example for us. All right. So let's see. Yeah, when we go to plug this in, this is going towards f of 5 is 5. And if it's differentiable, that means it's continuous, so the value of its limit is equal to the value of the function. Haven't had anybody complaining about that yet, but just in case you were thinking about complaining, don't. You know that that limit is going to be 5. And then we'll have a 0 squared when I plug in x equals. Okay, because this one's going to 0 over 0, I'm going to use L'Hopital's rule. Okay, so this limit is going to be equal to the limit of the ratio of the derivatives. Limit as x approaches 5 of f prime of x minus 1 divided by 2 times x minus 5 to the first power multiplied by the derivative of x minus 5, which is just 1. So I'm good there. Go to plug in 5. F prime of 5 is 1 minus 1 divided by 2 times 0. Okay, this is 0 over 0 again, so I got to use L'Hopital's rule again. Okay, so now this limit is going to be equal to the limit as x approaches 5 of derivative of top, derivative of bottom. Okay. If you were to multiply that out, it would be 2x minus 10. That derivative of that is 2, or just whatever you want. And however you want to look at it. You can even do the product rule on that. I wouldn't recommend it, though. And then f double prime is -1, so this ends up being -1/2. Okay. This is another good example of L'Hopital's rule. Oh, this ain't going to show up on the test. So what I might do instead is I might draw your attention to one like this, and number 11. Just don't forget, you've watched with me all the way through, viewing for your test or whatever. Don't forget that some limits don't come back 0 over 0 or infinity over infinity when we go to plug in on them. Right? If we go to plug in b approaching 1, this limit is going towards 1 to the 9th. Any power of 1 is 1, we know that. Minus 5 divided by 1 minus 1. That's a number divided by 0. That limit fails to exist. Okay, so you just say d and e. Okay, it's probably going to be e to the 5 minus 1 in the denominator. No, it's going to be infinity from one side, negative infinity from the other. So we just say d and e. Just move on with our lives. Okay, and then this one, I think I remember that, yeah, this one is going towards 0 on top, but 1 minus cosine of pi is -1, and that's just equal to 0. Right? So remember that occasionally some of these limits are not going to come back 0 over 0 or infinity over infinity, and you do not want to just immediately jump to taking the derivative of top and bottom. And is that likely to happen on your Unit 5 test? No, not likely to happen. But I did grade an AP exam question summer before last where it was one of these kind of fake L'Hopital rule questions, and you'd be amazed how many people fell for the trap and just didn't even check that it went to 0 over 0, didn't even show it, didn't mention it at all, just went straight to taking derivative of top and bottom. And they got no credit. And I don't want that to be. Okay. So I think that's all I got for you. Thanks for watching.